Click. Talking. And hello. Start recording. I'll do when we start a
Okay.
Sudoku. Uh, I guess it's not really like important, but I guess I feel it would be I don't know. It just saves like the amount of time because I've got a bunch of recordings saved.
Right.
Yeah, if I go into capturing, which is where all of the files are, there's just a whole bunch of things that are just date stamped. So eventually I'll go through and try and pick out all of the Sudoku puzzles we've done and upload them individually. Hopefully that'll I don't know, I'll just put them in a playlist and then people can like watch through them and hopefully solve them. Because I think they're fun. But how are you doing, Mama? What else have you been up to?
Work. It was very hot, so
Yeah.
I mean, over the weekend or my weekend, whatever. So I didn't do much.
Mm-hmm. Yeah.
I avoided the outside.
The outside is very unpleasant. It's I looked at the prediction for like the next 10 days, and it's also supposed to be like still above. Well, the highs are predicted to still be 80 to 90 for the next 10 days. So that's not fun.
Yeah.
And despite having the AC, like a one of them portable AC things in this room. If I don't have it
Uh-huh.
on the right setting, it can still get up to like 77 in here. So unfortunately, that has to be on like all the time, which is really annoying. But yeah, the heat is not pleasant.
No.
I haven't been up to that much either. I don't think I've done anything super exciting. No, I haven't. Maybe gonna start another tabletop RPG game. That'll be fun. Had been playing in a campaign with a friend of Sarah's for a while, which has been pretty fun.
Sorry, I sent you
That's
something.
oh okay. Um, I guess I can take a look at that on my phone. Today I learned there's a word in ancient Greek, uh, akotharies. I'm not sure how to
No clue
pronounce
how to
the E.
pronounce it.
Yeah. That means bad at summer or unfit for summer. And it pleases me to know that this has been going on for thousands of years, for I too am bad at summer. Yeah, that's hilarious.
I thought that fit me very well.
Hmm. Alright, then, let's hop over to some Sudoku. Um, our first puzzle today is That's All the X's. Sorry, first puzzle today is That's All the X's by Rock Rat Zero. I'm not sure if there's a different way to pronounce that. Yeah, I don't know. Getting caught up on a name. Normal Sudoku rules apply. No digits repeat along the marked diagonals. Digits in cages must sum to the indicated value. Digits on a purple line. Each line in this puzzle contains 5 cells. Form a set of consecutive digits in any order. Digits in cells connected by X sum to 10. So all of these Renban lines are one group, and they're not like
Right.
two different sets.
Yeah. And they all have to contain the 5.
Yeah. Now, I guess. Um.
And the 5 cannot be in the center of any of them.
Right. I guess there's a
Which
part
would
of me that
put, wouldn't
wants.
that put 5 in the center of box 5?
I don't think so because. Oh, right, because in this box, because it has to be on the Ren band,
And
then
it can't be on the
yeah.
center.
Okay, yeah, that makes a lot of sense. Because then, where is it in this row? Well, it's not here, it's not there. Where is it in this column? Well, it's not here or here, it's not on the X, not here or here, not on the X. So then it must be in both the column and row, and there's only one spot for that. Yeah, I guess the next thing here is to maybe start painting these X's. Say this is red.
Or we can look at the 10 cage in box 1 and the 30 cage in box 9.
Those are highs and lows. Except on the diagonal. Oh, got that one
No.
completely backwards. Except on the diagonal. Which means these ones are low digits. So maybe instead, hold on. I'm just going to paint these as low digits and high digits. And this one has to be low, this one has to be high, which means these are low, which means these are high. Although I guess there's still a part of me that wants to do painting the tens individually.
That 13 is 4 and 9 because it can't be 5 and 8 or 6 and 7.
Yeah. And so the across the X is going to have to be 6 or 1. Now, a 9 gives them a lot of freedom, but a 4 would end up being quite restrictive. Because of the 6. It would have to be 1 through 5 in that case.
Right.
Although I guess the 4-9 does that automatically as well, because if you put a 9 here, then you've got the 4 there, and they're all the same. Oh, this is a high digit, which means these are all high digits. Except for whichever one is a 5. But this has to be 9 and 4. Because if this was a 4, then you've got a 6 here. And since we know that this one's a high digit based off this here, how do we get to that high digit? Because it's going to have to be a 7 or bigger. Because it can't be 5. But the only way to get to that is through the 6. So, because we know that, this is a 1, this is a 9, this is a 4. And then these are going to be a 2-3 pair, which are low digits, pairing with our 1-4. Red 9, which I guess gives us 9s here and here. And that can't be a 9, because this would have to be a 1, which is already repeated, so we've got 9s here. This one must be a high digit, so this one's low, because you can't put a 5 here.
Right.
Which I guess means that 5 is down here. So that makes this a low digit. Three is low, 7 is high, 5 is in the middle.
In box 7, the 5 has to be in the middle. Well, no, it could be on the top. Never mind. Got ahead of myself.
Mhm. Trying to think if these have similar restrictions, um, especially thinking about their centers, because like I think in this case I couldn't put a 4 here because it'd have to put a 6 here, and then I have to get to this high digit, and again, just like down here, the only way to do that would be to go through 6 because it's not a 5. So then it must be greater than 6. So we know that this one's not a 4. In fact, could this even be a low digit at all? Because if it's a 1, it clearly can't get to a high digit at all, because that'd just be 1 through 5. But it could be 2. That would put an 8 here, but you can do 2, 3, 4, 5, 6. Although, no, that would be perfect. No, you couldn't do that.
Couldn't have a 6 there.
Because this would be a 4, and that would conflict. So that's not a 2. 3 would put a 7 here. But we already said this can be a 6.
And it can't be a 7. Well, if
this was a 3, it could be a
3,
7.
Yeah, and that's the only low digit that can. That's 7 is the highest a 3 can make.
Mm-hmm. So it's not a 3. So this is a red digit. But these have to be 7 or 8 because they can't be a 9 and it can't be a 6 because the 6 would pair with a 4, and these have to be the same because the x's mean they both sum to 10. Or that this sums to 10 and that sums to 10, and since you've got a shared digit here, that those have to be the same. But and a similar thing going on up here. 1, 2, 3, 4. Well, if this one's not a 3, that one's not a 3. So 6, 7, 8, 9. 3 removes the ability to do 7 there.
Okay, now in box 4, can the center of that X be high? And we know it can't be a 9. The lowest that 9 can go is 5. So it can't get down to the 4. 8 would have to pair with 2.
But then you put a 4 here, a 6, and a 4. So that can still work at the moment.
Right.
But a 6 would pair with a 4, so it can't be a 6. Because you couldn't get to 1 or 2 without going through 4. Well, you couldn't get to 1 at all, but you'd have to get to
2.
Yeah. But it'd have to go through 4. 7, 6, 5, 4, 3 is perfectly fine.
But 3 would have no, because the 7 would have to pair with the 3 in the X.
Oh, right. But you could go. This could still be a 4. So 7, 6, 5, 4, and 8 would still be fine. Yeah. And then 8 to get to 4 is also fine. So 2, 3, or 6, 7, 8, 9.
The center in box 6 can't be a 7 because that would pair with a 3 across the X.
Oh, right. And we know this is a low digit now, so 1, 2, 4. And I guess this top digit, 1, 3, 4, 5, 6, 7, 8, 9, never 5, 4, 7, and 9. So that's 4, 2, and 7, 8, 9. But it can't be a 6 for similar reasons as before, because this ended up being a low digit. 6 to 4. But 8 is perfectly fine for the same reasons it's perfectly fine over here. Oh, one of those two is 7, because it can't be in the 10. It can't be here, because that would put a 3 there, which conflicts. And it can't be in here, because there's already a 7 in here. So it has to be down here, which means it has to be in the 30 page.
Well, in box 5 on that same diagonal, one is high, one is low.
Yeah. Which means one of these is high and low. Or rather, the pair going across the middle is high-low. Well, this 16 can't have a 9 in it, but that's not too restrictive. This 12... and it doesn't even have to have 2 low digits.
The 16 again, please. Okay.
Has to have a 7 or an 8 or both. Is there anything more with the 16?
No, probably not.
Because I just noticed that this red digit up here has to be 7 or 8. Because what can this be? Well, this cannot be a 9, and if this was a 6, that would be a 4, so that made that all restrictive. So this is a 5, 6
It can't
pair.
be a 7
This one?
because 3's already on the diagonal.
Right, so 2, 3, pairs of 7s, 8. Which takes 2's out of these two and an 8 out of there. 7 and 3. 8 and 2. So 2 is now one of these two, which I was about to say pairs with this to put a 2 up here, but I mean, that's how I got that far to begin with. So 16 can't have a 2 in it. That doesn't help that much. And now this has to be 1 or 4. 7 and 8 can still get to 4.
Right. Box 4,
Mm-hmm.
you can't have an 8 on there because there'd be no place to put a 7 on the Renban.
Oh, right.
Because
7
there's,
has to be in the middle now.
yes. And the 7 in box 2 has to be on the left side.
One, 3, 7, 3, 7, and 1 takes 9. And then 2 from the diagonal.
Right.
8.
The left one can't be a 9 because it can't get down to the 1 or 4, the low in the...
Right. Now, if this was a 6, this would end up being a 1. Because 6 would be removed from here, so 9 and 1.
Would make
So
that
this
9.
can't be a 6.
No.
Because you couldn't pair 1 and 6 together.
Right.
So this ends up being a low digit. And now 8, I don't think gets down to 2 low digits,
Well,
because 8, 7, 6,
can't.
5, 4. So that gives us 3 low digits. A 5. I don't know if we're guaranteed to not have 6. I think it's still theoretically possible.
I think it's possible.
This ended up being a high digit now. But we can't have a 7.
Right.
So 7, 3, 2, 3. So this is 1 or 4. 1, 4, 5. Not a 4, so that's a 4. This is 9 and 6. We don't have 6 in here.
It can't have 2 on the 6. Oh, we already know it can't have 2 on the 16. Never mind.
9s, 7s, and 6s. Well, this has to be 1, 9 or 3, 7, I think.
Yeah.
Two, four,
and it
5,
can't have
6.
9 on it. It can't be 1, 9 because the 9 is up top.
Right. So this is a 3, 7 pair. Then we have 8, 9 over here for a 1. So that means we have to have 7 and 8, because 1 and 3 is 4, and we can't put 12 in a single digit. So 8 and 8 more finishes that. So 5 and 4.
And 5 is on the diagonal.
And that's all of the low digits for here. So this ends up being a 1 and a 9. 4 and 7 is not allowed, so 6 isn't, and you can't have a 3 there. So this is 8 and 2.
In box 3,
Yep.
the diagonal, the blue diagonal, is 6, 7, and 8.
This
Because
one's
that's
not a
all it's
7. 6, 8 makes that a 7. The 7 from down here. Red digits. 7 needs 5 left over.
Can't be 3 with the across the X, because that would pair with 7.
Right. So that's a 1-4 pair, 6 or 9, which it can't be a 6 because of the 6 here. So that's 9, 1, 4, 1, 9 is out. 2, 3, and 5, which this one is a 2 or 3. Low digits. No, that one's 1. This one's 5. This is the 1 here. 6, 8,
1.
1.
But the 7 can't get down to 1 on the Renban.
Right. So that's a 1. 6, 8 pair. And we know we have to have a 5.
And it can't go down to 4, so it has to go up to 9. Because there's a 4 in the column.
Right.
Which resolves box 9. Two, three, 4. Box 2,
That was resolved, so that's going to fix this, which is going to fix those. This is that, which is already done. But this is 3, 4, and 5, which we've got a 5 here. 4, that's a 3. Those are low digits, though. 7, 8, 9. Not an 8, obviously, but this one is red. 7, 6, 9. 6, 9.
row 6 needs a 6.
Row 4 needs a 2. And a 4, 8. 8, 4, 5, 6. High digits, low digits, middle digit. I need a 6 in the middle row and an 8. This is 2 and 5, so this ends up being 9, 2, 5. This is 3, 4. Means this is 1 and 2. This is an 8. I need a 6 here. 5 and 7. And we're done. 23 minutes and 23 seconds. It was a good puzzle.
That was a nice little puzzle.
Alright, puzzle number 2. Ring Cycle by Austin C. Normal Sudoku rules apply. Within a cage, digits do not repeat and sum to the total given. That's it. 7, 1, 2, and 4.
Box 1, the 11 cage is 1, 2, 3, 5.
And not a 1 from down here. Not a 3 there. Because the 10 is 1, 2, 3, 4.
Column 9 has a 5 cell 35, which would be 5, 6, 7, 8, 9.
So 1, 2, and 4. And of course, we've got 1, 2, and 4 left in the 10 cage. So this is 5, 6, 7, 8, 9 in the rest
that's
of
a
the
16.
box. Which can't have a pair of 8s, can't have a
It's a
6
7,
or
9.
a 5 in it. Can't put an 8 here. So this is either a 1, 3 or 1, 2, 3, and 4. Finish out 10. Not a 5. Not a 1. 8. Well, it has to have a 1 in it. Yeah. 3, 4, and 5. These two aren't 2s.
Oh, well, columns 8 and 9 is all but one cell are caged.
Yeah.
So there's a 10 and a 35 is 45. 26 and 12 is 38, so it needs a 7.
And I just realized the 7 pokes into the box with this 11, which has to be 1 and 2. So that's a 4.
Oh, box 5, that's a 5 cell 35 cage. So it's all high on the inside and low on the out. So row 4 has a 1, 2, 3, 4 quad. Box 4 has a 14 cage that can't have a 7 in it.
Right.
And box 7 has a 14 cage that can't be the same as this box 4 14 cage.
Mm-hmm.
Let's see it. The 15 cage in box 4
This can't be 6-8.
can't be 6-9. Well, I was going to say the cage can't be 6-9.
It's the same logic, just in sort of different directions.
Right. So the 7-8 could come out of row 6 and the 6-8 in row 7.
All of this is just sort of falling in. 9, 7, 4, not 4s. Flipped over 5, 7, and 9. I could still put a 9 right here, because that would be a 1, 2 pair. Where that's the 1 and that's the 2. Oh, this 4 is not over here. This one's not a 2. But I'm not sure yet.
Row 1, the 17 cage in box 2, that has to sum to 10. Well, there's a 2, a 3, and a 9, which would be the 1. So the low would have to be 4.
4,
4,
6,
6. Yeah.
8, 6.
And the 4 is resolved in box 3.
Right. 1.
Or, well, what 4 is taken out.
Right.
Whatever.
These 3 are
5, 8,
3
9.
9. This one's not a 5, and this is 1, 2, or 3. 2 though. One of these two has to be 9, so this is an 8. One of these two has to be 8, so this one is not. 1, 2, and 3 left over.
Box 6, the 1 has to be on the left side. So in box 9, the 1 has to be on the right side, and there's only one spot for a 1.
And then the 1 in this box, box 8, is now removed from the bottom 2 rows. It's clearly not a 2, so it has to be in either cell 1 or 3. And if we look in box 5, it has to be in the same columns, which means that the 1 has to be here in box 2. We're just going to resolve quite a bit over here. 1, 2, 1, 3, not a 3, not a 2, not a 3. If this is a 3, then these must be 7, and if this isn't a 1, then that has to be 5 and 2. 4, 3, 1, 2, not 2s, 3, 1, 4, 3, that's 7, so this is 1, these aren't 5s, 6, 6, 4, 3, 2, can't have a 9 with a 3, because that would already be 12, so that's 8 and 4 is 12, 9 here, out of there, not a 6, 5, 6, 7, 8, 9, 7 and 8 are out. What are we missing? These two are going to be 6, 8. So these two are 2, 4, and
26,
5.
36, 8.
And 2, 4, and 5 is 9, 10, 11, and a 1 is 12. So that works perfectly fine.
See. All right.
6, 7,
rows
8.
8 and
Is that
9.
8, 9.
Yeah. 17 and 18 is 35 and 10 is 45. So 12. Let's see. 16 and 12. 16 and
28.
12 is 28.
So
So
we
and
need,
17
which has to be an 8 and a 9.
and a 9.
That's a 6, a 7, a 9. I
That
need
comes to
11, which is going to have to be 3 and 8.
3.
3, 7, 9, 6, 8, 5, 9, 8, 9, 6, 7, 6, 8. Those aren't resolved yet. 2 and 3. What's left over for this? This is 4, 5, and 2. 4 and 2. I need a 5, a 6, and a 7.
Nice.
It's a nice little
927.
puzzle.
It just kind of fell together.
Mm-hmm. Yeah, it was really well constructed. That you didn't need. It was the construction was fun in the way that like you've got to do a lot of the things like this 7 and how it overlapped with this 11, the getting this 7 and this 8 9 pair from the sums, the rows and the columns, and it wasn't like super
Right. Well, and the 8 there in row 1, just because rows 1 and 2, those had all but one digit filled, or well,
right.
sums.
That and 8 and 9 columns.
Yeah. Yeah.
So.
But then once we had, the 7 and 9 in rows 8 and 9, it gave us that pair, that 17 pair too.
Mm-hmm. All right.
Oh, I guess columns 1 and 2 had everything but a 4.
True. There was
I
a lot
didn't
of
notice
those
that
little
until
spots.
now.
And we didn't need them in that many positions because we really just did this 7 and this 8, 9. That was all.
Yeah. Well, because the row columns 8 and 9 were the first ones I noticed. I didn't even notice the rows 1 and 2.
Yeah. And columns 1 and 2. Probably would have been faster if we had spotted those, but all right then.
Well, I mean, we already knew because like the 11 cage was what it was. The 10 cages were what they had to be. So it was.
Yeah.
So yeah.
Yeah, there was a lot of heavy restrictions based off of the cages. Yeah, the most freedom was down here in this corner. Anyway, alright, let's move on to No More Tens by Koopa Nooba. Normal Sudoku rules apply. Adjacent digits along a green line must differ by at least 5. A killer cage is a set of orthogonally connected, non-repeating digits. Killer cages may overlap. All killer cages of size 2 or 3 summing to 10 are given. Cages of size 4 summing to 10 might or might not exist. Well, okay then. I guess I'm not sure what the point of cages of size 4 summing to 10 might or might not exist means.
I don't know.
But the killer cages of size 2 or 3 summing to 10 are given means that we cannot put like 1, 2, and 7 together. Or
Right.
like
Or 1
that.
and 9 or 2 and 8.
Yeah. So I guess here we've got purple and green. I think those contrast well enough.
Well, if purple is low,
Mm-hmm.
4 can't be in box 2. Or on the purple, anyway. That would have to be 1, 2, and 3.
Mm-hmm. You couldn't put 6 on here either.
Yeah.
Not sure where to start. I guess. Hmm.
Well, okay. We know in box 2
Yeah.
that purple, let's say purple is high.
Okay.
We know it can't be 6 on there, but there's a problem with 7. 7
Okay.
has to be bounded by 1 and 2, which sums to 10.
Right.
So you can't put 7 in any of those.
So we know that purple is low then.
Low.
We know these aren't that. And we have red instead of green.
And
And
7 won't be able to be, those can't be 6 or 7.
mm-hmm.
Okay, 8's going to have to be bounded by 1 and 3.
Right.
9's going to have to be next to 3 and 2. So
this
3
couldn't
has
be
to
a
be in the
1.
middle.
Right. Because that prevents 7s,
Right.
or not
And
7s, 10s. So 7 is going to have to be one of these two.
Yeah.
Five is going to have to be carefully placed as well.
Yeah.
I guess we've got 4, 5, 6, and 7. We know you can't put a 7 next to a 3. Wherever the 4 is, the 6 is in the other group. And if 5 is either of these two that are next to the 3, it would place the 1. Because 5 and 3 paired with 2 is 10.
Okay, if we look at the in row 3, the green line there, if 8 and 9 is going to be eliminated from the elbow on the right. Because if the one on the left is an 8, then it's a 1. Well, you can't have 9 next to 1 because it sums to 10.
Right.
And the same thing if it's not. So that's... And if it's 7, they have to be either both 1 or both 2.
Mm-hmm.
Of course, 6, they would have to both be 1.
So they're the same regardless.
Well, isn't 8, 9 eliminated from the other end? Because if that's an 8,
Right,
1,
yeah.
and it can't be 9, yeah.
Same logic. Taylor cage is a set of orthogonally connected, non-repeating digits. So if digits repeat, that blocks the cage. So if these were a pair of 2s, this could still be a 6.
Okay, on the 3 line on row 1,
Mm-hmm.
German whispers line, that's what it can't have 1 or 2 on it because the 1, 2 in row 1 is different from the 1, 2 that's already in box 3.
Right.
So, and
So you couldn't put 6 anywhere or 7 anywhere.
if it's 3, it has to be an 8-9 pair.
Yeah.
4, 9, 3.
Well, the middle couldn't be an 8. It has to be 3 or 9.
Right.
But it couldn't be, you can't do a 3 and an 8-9 pair, because there's an 8-9 there. So this has to be 9, this has to be 8. 1, 2, 9. This is the same regardless, because if they're different, well, 2 and 7. and then you can't do.
Right.
We get it. 3, 4 takes the 4 out. That can be 6 or 7. That's perfectly fine. On the 7, I'm gonna go ahead and remove the coloring. We need it.
Okay.
And we might want it for something else.
In box 2, that can't be a 5 that you just highlighted.
Right. And this one can't be a 6. It's 1 and 3 plus 6.
The one on the right where the 5 had to come out, the 6 has to come out also because they can't.
Non-repeating digits.
Non-repeating. Okay, so the 2s don't matter.
Yeah. Now, where can I put 1 in, 2, 3, 4, 9, and 7. I couldn't put 1
go next to 9. In
ever.
either of those, yeah.
And it can't go here either because you'd end up with a group.
1, 2, 7, right.
You can't put an 8 next to a 2 ever. So 4, 5, and 6 triple. 5 and 6. 4, 5, 6,
1,
3,
7,
and
8,
2.
9.
Can't eat that anymore. Oh, where's the 7 in here? It has to be here now. Which means this is a 4 and that's a 3. This is a 6.
Which leaves 2 and 5 in row 1. Four and 3 have to go in the bottom. And
2, 5, 7, and 9, and 6 is out. So we know 4 and 3, like you just said. So that 4 comes out of this one. Oh, and I guess this 5, 6 has to be that digit. So the 4 had to be there. That could have helped sooner.
Box 2, the coming down the right column or the left column, it can't be 1, 4, 5. But it could be 1, 5, 6.
But that means this has to be a 6, doesn't it?
Yeah, because if it's 4, it has to be 6, and if it's 5, it has to be 6. So yeah.
Six can't be next to a 4 ever.
Right. Oh, box 3, that can't be a 1 there. You just highlighted because of the 6, 3.
Right. So that's going to have to be like that, and like that. And, well, this is 1, 7, and 9, which means we need a 7 to separate the 1 and the 9. So you can't put a 3 next to 7. And you're going to have to put a 1 here.
Well, I was going to say you have to put a 2 in the top row.
So it can't be next to the 7.
The 1 on the left. Well,
That too.
if the one is on the left, then it's no matter which one it is the two, it would be orthogonal. So that's the 9.
Right. You can't do
So how did that
6,
get
1,
to?
3. So 8, 4,
Oh,
and
because
3.
oh, not bad. We went from having no clue how to start this really to we have the whole
Yeah.
top 3 boxes done.
Well,
All
this
right,
is a group of
10
10.
and 3.
So that's 1 through 7. It's not a 7, a 4, and a 5. If it's not a 6,
So it's
then
got to
it
be
doesn't
1.
work. So we take the 2 out. And so what's left over? Well, 2, 8, and 9.
Right, and that 10 cage can't be a 6 in the middle because it would have to go to 2 ones.
Right. So this is
So
a
those
low
are
digit.
high.
8 and 9. This can't be a 7. Because if it is, that has to be a 1.
It has to
And
be
that would
bounded
have
by
to be a
1 and
2.
2. Yeah.
So this is a 9. And so this can't be a 1, so it's a 3. Which means this isn't 6 or 7, it's an 8. A 2. Not a 2. And what's left over in this box? 2, 8, 3, and 9 are all out. 1 and 6 are out of those. 7 can never be next to 3. Now we're
You can't have
allowed...
5 there. You can't have 5
Right.
there because it's...
Because it would pair with the 2 and the 3.
Right. Oh, the bottom left corner of box 4.
Oh, 7 can't ever be next to 3?
Right, and it can't be...
It can't be 1 or 6, can it? Because the cages can
can't be
overlap.
1 or 6. Right.
Four and 5 aren't going to be a problem, I don't think. But this is a 4, 5, 7. So this isn't
Right.
a 4. Two, 3, 4, 5, 7. 2, 3, 4, 5, 7. And 7 has to be one of these two, so it's not there.
Okay, the 10 cage in column 4. It's got to be either 2, 8 or 3, 7.
2, 8, 3, 7. This isn't a 3, so that's not a 7. Looking at this group, if the 4 was not down here, it would be 2, 3, and 5. So that means we have to have a 4, don't we?
Yes.
So that means the 4 is out of there and placed here.
Okay. They're in box 4, the 5, 7 pair. One of those has to be a 7. So if you have a 1 in the top of that 10, it's going to be 1, 2, and 7 orthogonally one way or another. So that's
6,
the 6.
1, and 1. And this can't be the 7 now because it would be 1, 2, 7 going across. And that is our 4 cell
Right.
10 cage.
So column was 5, 6, 7. And it can't be 5 in the top because the 1, 4.
Right.
It can't be 6 because the 1, 3.
Or just simply 6, 4, but 7.
Or well, that too. Oh, underneath the 1 can't be a 9.
Right, so 8, 9. Can't put a 2 next to an 8.
And you can't have 7, 1, 2.
Right. So this is 2 then. Maybe we do this 10. Has to be max of 7. You can't have 3 and 4 in the row. This isn't a 1, a 5, 6, a 2, or a 7. Well, the only low digits are 1 and 2.
Because you can't have 1, 3.
Right. And then 5 is going to have to require another 5, which is going to be 2, 3, or 1, 4.
Yeah, it's got to be 1, 2, and 7.
So this is 8 and 2.
Which leaves 5, 6 in the row, in row 6.
What's left over in this column? 5, 6, 8, and 2. Not a 7, also not a 3. And this isn't a 9. Can't put a 4 next to a 6. Okay. If this was a 9, this would be a 4, and this would be 3, 7, which isn't allowed. So this
Right.
can't be a 9. But now that we know it's a 3 or 7, then the other of 3 and 7 has to be over here, which can't be there because it sees both. And these can't be 7s, so we have to have our 3 over here, so this has to be 7. Yeah, so where could 7 go? It couldn't go there. Those wouldn't have the ability to be 7. That was 3 or 7, so that can't be a 7. So yeah, that was the only spot 7 could go.
Yeah. Where can 1 go in box 5? It can't go across the top, can't go across the bottom.
It's one of those two. 5, 6, 7, 8. Apparently, this is not 1, 2, 3, or 9, so that's a 4. That's a 9. Can't put a 1 next to a 9, and this is already not 3, 4, or 9, so that's a 2. 2, 1. Well, this has to be a 1 now, and a 3. There's another of our 4 cell, and there's another 4 cell.
Right.
10 page, but this isn't a 9. Lots of 4 cell 10s in that group.
Well, column 5, or you could just do it that way.
8, 3, 9, 4, 2. This one isn't 1 or 7. Well, that means these aren't 5 or 6. And 7, 4, 2, 3, 1. Not an 8 and not a 9. I don't know if that's going to cause problems. I guess if this is a 5, that's a 4. Because you couldn't put a group of 5 like that. Or
Right.
5 and 5 together. But if this is a 6, it doesn't mean anything for that.
Right. Well, it just can't be 3 and then 1 beside the 3.
Mm-hmm. Although, if this is a 3, that's a 1. So, does that mean this is a 4 in either case? Because
Why,
the
if that's the
3...
3, that's a 1. Oh,
Because
because it
3
can't
and
be
7
7.
have to be diagonal from each other.
Right.
So, is this a 4 in either case, then? Because 5, 2 would need a 4 to avoid being 10. And if this is a 6, you can't put 3 and 1 together. So this is a 4 in either case. This can't be a 6, because then it would be 1, 3, 6.
Right.
I guess we've got one more 10. And this is not 3. Well, these are not 3, 4, 7. This one's not 1. And these are not 5 and 6. And this one isn't 1, 2, and 3. So if this is a 7, then we've got 2 and 1. And if this is a 4, then I need 6. But I can't put a 6 in either case, because I would need a 1, 3, which I don't have.
Right.
Because of that. And if this is a 5, then that's 1, 4. If this is a 2, then this is 1, 7. Wait, did I just prove that this
That's
is a
a
1 in
1.
either case?
Yes.
I guess if it wasn't a 1, then you'd have 2
If
and
it's
5.
4, it's 1 and 5. It's 7, it's 1 and 2. Yeah.
Yeah.
2, 5, 6, 9.
2, 5, 6, 9. This isn't a 2 because the 2 above it, and it still can't be a 9 because you could never place a 1 next to a 9.
5,
So
6 pair. In the row.
That's 2 and 9. 7 and 2. And this is 3, so that's a 7. 5, 6, 8, and 4, I think. Or this isn't 4, so that is. One, 2, 7, and 4. This isn't 5 or 6 or 9. This isn't 3 or 8. And
8 can't go next to 2.
right, so that's 3. That's not. You can't put a 6 here, because there would be multiple ways to do
Right.
problems. Same here. You can't put a 5 here because 2, 3, and 5, so that's a 9.
In go down 1. That can't be a 6 because
Yep.
of 1, 3.
6, 8, 5, 6 pair makes that an 8, 5 and 6. And what are these two? 3 and
9.
5? 9?
9.
Then I need a 4.
Need a
5, a 6,
6,
and an 8.
and an 8.
Okay.
All right.
1 and 3 means
3
this is a
can't
5.
be 6.
There we go.
28,
That
46,
was,
not bad.
yeah, that was daunting. That was pretty.
I don't think we
Uh,
really got stopped though.
yeah, it was just intimidating at the beginning because of just sort of like not grasping immediately the impact
Right.
that it had. And I'm not sure how long it would have taken me to see what you saw in here in box 2 at the very beginning, which got us started
We
by
can't have a 7 at all.
exactly. Um, but I don't think there's another way into the puzzle except for that start. So
Yeah.
that would have taken me quite a while to find, I think. Or at
Probably if
least just to
I would have taken
consider.
you that long, it would have dawned on you. Oh yeah, 7 has to be bounded by 1 and 2. That's a 3
Mhm.
cell 10 that's not allowed.
Yeah. But I think I would have been staring at the puzzle for some time before considering that. Yeah, that was really good. The way that it just sort of fell apart as we got through it. I guess the thing about this last part here, the cages of size 4 summing to 10 might or might not exist. Just sort of, I guess, reminds you that you can have 1, 2, 3, 4, but then also saying that it's fine when those happen, because
Right.
that might make you feel like the puzzle was broken if they didn't acknowledge it. So that's just one of those things where it's better to mention it in this kind of ambiguous way without uh, uh, ruining the puzzle, I guess. For those who would be like wondering, well, can I do that? So, all right. Then, anything else about this puzzle?
Nope, I liked it.
Yeah, I did too. All right then. Fourth puzzle today: Polarity Loop by Yitrio. Normal Sudoku rules apply. Digits in cages cannot repeat and must sum to the small clue given in the upper left corner of the cage. Cells separated by a white dot contain consecutive digits. Not all dots are necessarily given. Draw a 1-cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. The loop must occupy all cells of all given cages. Adjacent digits on the loop must alternate polarity, low versus high. So we're supposed to draw a German whisper line around it.
Right. I was gonna say you can't have a 5 on there, so
I guess it's not necessarily a German whisper line. It's just
right, but
a high-low. But I guess all right. It has to go through all of these. So I'm going to mark them in green. And it's not possible for
and it
it to
has to be
cross.
high and low. So the 7s have to be 1/6.
That's true.
And the 13s have to be 4/9.
That's also very true. And then extending these ones in the corners, it's going to have to go down here because the corner, and then since it can't touch itself orthogonally or diagonally, it's going to have to extend towards the center.
Right.
But this one isn't going to be allowed, nor is that one. Oh, which means, I guess, clearly means that has to extend farther down. And we know that we can't ever cross through the dots.
Right.
Because the closest you could get is a 4 or a 6 trying to reach to a 5, but then it wouldn't be high versus low. Well, I guess what's going across the row here? 1, 6, and 4, 9, and we don't have 5s in either of those positions. One of these is a 5. Well, okay. Well, I guess we don't know how this is going to end up. Well, however this goes across through here, if it even does, it can't go straight across. It's going to have to go down.
5.
And if it goes down, then it's going to have to connect to the 7. Because it can't, like, ignore the 7. Because then it would touch diagonally. But plus also it would end up touching itself, or just simply, I guess, touching itself in this direction if it tried to go past the 7 this way. So one of these two is going to reach the top of the 7. The other is going to have to come down and might grab the bottom of the 7, maybe? Not sure. Because it's a singular loop.
Right.
We know that 5 is never on the line, but whichever one of these steps inward, if either even do step inward, they could both step downwards. But they can't both step inward.
Right.
Because if they did, then you'd have a 5 in the middle, and they'd both have to step down. But then they would both touch the top of the 7. So one of them is going to have to go down here. And when it goes down, it's going to have to go down again. If they both go down, then this isn't relevant, I guess. But then this one on the right is going to have to go to the left. Because it couldn't go right, it would end up in a singular loop. So I think, based off of that, this loop, or this part of the loop, reaches to the top of the 7, no matter how it gets there. And this one's going to have to go down. Does that seem reasonable?
Yeah.
Okay. And so, since this one touches the top, this one cannot go to the right. It can't go in, and it can't go to the right. So it's going to have to go down. Now, it can't go left, so this one has to go down. and it can't go right, so this one has to go down again. If it went here, it would touch diagonally. And now, again, because this part gets to the top, this can't go here, because it would touch the top again. So that one's there. This has to be green, and now it can't go to the right, so that has to be blocked. So this has to go down, and now that has to be there. This has to continue. This can't go down, so it must go to the right. So now these are blocked, so this continues to go down, and now this must connect here. And now we end up with all of these being blocked. Okay. But now I've got the ability to set a pattern, and because I know that these are connected, and I know that they're connected orthogonally, I know that their pattern isn't going to change based off of how they connect. So I can just calculate the distance between those, and even if a more complicated path were to be created, it's going to have to still be the same polarity, if that makes sense. So let's just do this part first. So let's say these are the purple half. Then if this took the simplest path of just up and to the right, then this would be purple. And if we tried a different path, it would still be purple. We could go this way, it would still be purple. There is no path that connects these two that doesn't make this purple. So we know that these are purple here as well. Now, this path down this way cannot skip around this 13. Because if it did, it would eventually come back to the 13, but then we wouldn't be able to loop back out. So this must connect to the 13 here. So this ends up being green, because we go purple, green, purple, green. However we connect there, no matter how complicated we make that path, although it's not got too many options. This one ends up being
Right.
purple. Then where do we go from here? I guess because we know that this has to connect to here, there's no way that this skips around the 7. Because in order to do so, it would have to go into this gray region, but it would touch the loop up here. So this has to connect to the 7 this way, so that would be green, purple, green, purple, green, and purple. And again, there's no way for this to come down that would skip the back half of this. Because it would end up having to connect to itself incorrectly. So we've got that part situated. So where do we go from here?
Well, box 4, you can place a 5.
Oh, right. because 5 has to be one of those two, so that places the 5 here.
And in box 7, the 5 is on the left.
Oh. This 5 fixes the low highness. Because if this was a 4, then that would also be a 4. Because we know those have to be the same. So this is 6, this is 9, and all of our purple digits are high digits, all of our green digits are now low, and so that fixes quite a bit of things. And these cannot be 2 and 3, which takes the 7 and 8 out of here. This ends up, because of the 5 here, this ends up having to be red to continue the path. Because
it can't
if
go
this
through
is
the 5 in it.
Exactly. So if this was the 5, it would go around this way, and if it went down, then places the 5 here, so it would have to go this way anyway. And you can't go around this way, because then you'd end up touching the back.
Right. And it can't touch itself, so it's gray above the 9.
Right. And so this ends up being blue.
And all the reds are high.
Uh, 7-8 pair makes this a 9.
Box 5, a 6 comes out, and then it's above the...
Or, well, I guess this is still 7, 8, 9.
Right.
I don't want to mark it in red because that's the...
Right, because it's... Yeah.
Well, one of these has to be a 4. Because this 4, removing it from the middle. Oh, where's 1 in this column? It's not in box 1. It's not here in box 4. It's not 5 or 6. It's not a 9, and this 1 removes it from there, meaning that's a 1. And this is not on the path, because it would end up touching diagonal.
And if you look at that column, all that's left is a low 2, 3, 4. So that's a 2 or 3. Row 3 has 4 highs in it.
4, 4, 1.
But we know the 5 has to be in the top of box 2, top
Right.
row.
2, 3, and
I also
5.
can't 2, 3.
And that could go this way. Although, okay, it would have to if it went up 1, 2, 3, 4, and 5. This would have to be a high digit. In fact, we know that this has to be 7, 8, 9 across the middle. So in order to continue the path, it has to go here. And here, it can't continue the path because there's already 4 high. So it goes up, and then it can go to either of those. But these are gray. And so is this one. Oh, 7, 8, 9 triple, but this crocky dot
Has
here
to have an 8.
Exactly. So the 8 is out of this one. And then what's left over in the column, 7, 8, 9 is all
Low
out,
and
so it's
5.
6 and 1, 4 out of there. So 4 is one of those two.
Ah, but the blue 1, 2, 3 in box 8 can't go to the right
So it goes up,
because it's low.
it's not 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't go up now, so it goes to the right, takes out the 5. And it can't go up or down, so it goes to the right again for red. 6, 7, 8, 9, down to 6, so we end up with a 7, 8, 9 here, not a 9. 8 has to be one of these two, so that's not an 8, and that's not an 8. 7, 9 pair
Well,
makes
but
that an 8.
the 7 could go to 6 across that croppy dot. Can't it?
Yeah, it sure can.
Okay. Just making sure I wasn't missing something.
Nope, I got excited. And I'm glad you caught that, because if that
And that's
was...
all the highs, so that last cell in box 8 is low. Or 5.
And then across row 8, the two
Oh,
ends...
so we can place a 1 in box 8.
Sure can. It had to be down here, and it's not that one. And it can't be there because of the
Resolve
croppy
the
dot.
1,
So
4 in
4,
box
1,
2.
2, 3, 5. Although I don't think that was... all that stuff got resolved already. Yeah, and then all of this ends up gray. And if this went down, it would end up having to pass itself. So this all ends up gray. What's left over in this box? 7, 8, 9, 4, and 1. This one can't be a 6. So 2, 3, 5 triple makes that a 6. And it cannot be the path because it has to go through a low digit.
2,
And now we have a
pair,
7, 8,
no
9.
8.
And that would have been a big problem. 4, 4, this ends up being a 5, which cannot be on the path.
Kropke
2,
dot
3,
in box
5.
8. 6 goes to 7.
Right. Yeah, that would have been super confusing if you hadn't caught my mistake from earlier. 7, 9, 8, 9, 6. This can't be on the path. What's left over in this row? A 9 and a 4. That's a 4, that's a 9. This can't be on the path, so it must go up. Oh, this is an 8. 7 and 8.
Box 6, the red box isn't an 8. row 2, the 6 has to be in box 3. And it can be placed.
And it's not on the path, because the path would be red. So this one's blue, not a 5. This isn't a 6, so I don't know if that means anything.
6 can be placed in box 6, because by Sudoku.
Can. And it can't be the next digit on the path, so it has to go through here. Oops. This isn't a 5. And it can't go that way, so it's going to have to go down. 6, 7, 8, 9. I don't know why I placed a 6 in there. It could still
2, 3,
go
4,
to the
5.
left.
Okay, row 4, the 2 grays are left or high. 7, 8, 9.
And this one is 9. This one's a 7. That's an 8. 1, 3, 4, and 9. 1 and 4 are out. 2, 3, 5, and 9. 9 is out.
Box 4 can place the 1.
1. Left over in this box. 1, 6, 5, 4, 9. 8 out of cell 8. 2, 3 pair makes this a 7. Makes a 9. Which actually, 4, 9, 6, 7, 8 pair. And we know 2 3s out of the column. So this is a 1 and 5 here as well. Everything else is placed. So if it went down, that's a 1. This isn't a 9 over here. 2, 3, 4, so this is a 9.
Okay, in box 6, the center row has to be low or 5 because there's 6, 7, 8, 9 in that row. So it has to go straight down, otherwise if the path bends, that first one of that row would have to be high, and it can't be.
So you're saying it goes here?
It has to go straight down.
All of the high digits.
Yeah.
Okay. So we've got 2, 3, 4, and 5 left over. This is 4 and 5, but that's the full loop. 5, not a 5. This can't reach up to a 5 anymore. 2, 3 means that's a 1. Not a 5. 2, 3, 4 places a 5 here. 7, 8, 7, 8. Left over in this row. 1, 5, 6, 8, and 9. This isn't a 7, so it can't reach for a 7. It has to have a 3, so that's a 2. 2 is off. This is a 7. Those aren't 2s.
2, 3, 4,
so
triple
2,
in box
5,
6.
4, 3. 3, 4, 5. 3, 2, 8. 3, 8, 2. 3, 2, 3, 2, 4, 3. 2, 5, 2, 5, 3, 7, 2, 7, 8, 3, and 4, and we are done. That was pretty fun.
Yeah. And we still have 20 minutes.
Sure do. Alright, let's do the last, probably the last one for today, unless we get through this one in seconds. Foggy YYSL by Blobs. Normal Sudoku rules apply. Digits in large circles must appear in the surrounding 2x2 area. Digits separated by white dots are consecutive. Digits separated by black dots have a 2-to-1 ratio. Not all such dots are shown. Shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected, and no 2x2 area is fully shaded or unshaded. Digits in caged cells indicate how many cells of the same color, shaded or unshaded, are seen orthogonally from that position, including itself. The other color blocks vision. All dots lie on the boundary of the yin-yang pattern, i.e. each dot touches one shaded and one unshaded cell. Finally, the grid is partially covered in fog. Placing correct digits will clear the fog from surrounding cells, possibly revealing more clues.
I'm
Okay,
guessing
then.
YY stands for yin yang.
Yeah. I'm not sure what the SL is, but we will figure it out. All right.
Amen.
Start. Well, this digit has 3 digits consecutive with it. I think that's a 6, but I'm not certain.
It looks like a 6 to me. But
We don't know that this digit isn't one of those digits.
well, it has to be one of those.
Oh, that's true. Because
a
how else
digit
would
can
it
only
work?
be consecutive to 2, so.
Right. Okay, but knowing that doesn't mean anything, I don't think.
No.
It just means that this is 2 through 8. Alright, well, I'm going to say this is part of the orange group, just because I want to make it part of a group.
Right. Okay. Now,
Oh, we know that every digit is part, like, the dots are placed, all dots lie on the boundary of the yin-yang pattern. So, this is going to end up being part of, I'm going to call them the blue group. Which means that since this sees at least one more, because the other color blocks vision, it has to see this one. But then this one ends up on the other side. So this ends up being a 2. And we've got 1, 3, and 1, 3. And we've got a 6 as one of those 2. And we've got a 2 to 1 ratio, so 1, 3, 4, 6, and 8. We don't know if those are different, because those would be the pair that are the same. Okay, but one of the things is we know that the 2 colors are all orthogonally connected.
right.
So, regardless of how that works, if this was orange, then it would have to be orthogonally connected to this group of orange in some way. However, that would block this blue from connecting to all other blues. But even if we made this more complicated, it's still going to create a loop from which the blue cannot escape from. So this ends up having to be blue. And the same logic applies to this being orange, so this is blue. Now, this is in a cage, So it cannot. It automatically sees 4. So 1, 2, and 3 are all out. So this cannot be a 6 or a 1.
And it's across a Kropke dot.
So it must be orange. And this one must also be orange.
Right. Okay, in the other orange, they're in box 7. We know it has to be greater than 2. Not that that's very helpful, because it has to be greater than 4. Or 4 or larger, because it sees 1, 2, and 3 are in the box.
Right.
And it can't... Yeah. And it...
We know that one of these is 6.
Right.
If this is 6, it has to be orange. If it's not 6, the only way it's blue is if it's a 4. Okay. Let's ask a different question. If this is orange, how can these two be different if they're both orange? The only way that works is if this is blue. Because then this sees all of the same ones that this one sees, except for this one, and ends up one smaller.
Right.
If these are both orange. So this ends up being blue. If this is blue, then it would have to be a 4. So this ends up being blue regardless.
Yeah.
And now this sees at least 4, so those are all blue. Right?
Right.
Okay. I didn't talk over any logic that you wanted to do, did I?
Well, no, because I was gonna say, if for that corner that if it was orange, then the one beside it has to also be orange. Otherwise, it's blocked out.
Mm-hmm.
But if it was orange, then those two squares would have to be the same, which was basically the same thing as you were saying, but a different direction.
Yeah. Yeah, definitely this similar logic, but different directions, as you said. Now, this cannot be a 9 unless this whole column is blue, which I guess means that that could be a 9. Okay, but this has to be at least a 4 and orange. So 1, 2, 3, 4. If this isn't a 6, I guess if this isn't a 6, it must be a 7, doesn't it? Because this cannot be an orange 6.
Right.
So this is 6 or 7. And this is 4 if it's blue. 6 if the above is a 7.
Well, it can't be 5.
Yeah. Oh, it could be 5 if it's orange and the above is a 6.
Oh, right. Yeah.
And now we can't reach 9, we can't reach 4. 8 reaches 7, 6 reaches 5 and 7. So that is fine. But now we know that this is at least 6, so that's 1, 2, 3, 4, 5. Excuse me. And if this is orange, 6. But then blue must escape, which means this is now 7 or 8, which means this is also blue. If this is orange, then somehow this is going to have to connect to this patch of blue. But no matter how we do that, I have to lock out this orange.
Right.
So this ends up having to be blue. So it's a 4.
And therefore it's 4.
So 1, 2, 3, 4, 5, and 6. This sees all of the same digits that this one sees, plus 3. So this is broken somehow.
Yeah.
So, hold on. This doesn't have to escape.
Is that a cage?
Yeah, this one's a cage. The bottom left corner, no.
Well, then
Oh, then I don't know why.
it's not broken then.
Yeah. This is blue. And this has to see at least 5. But it doesn't have to escape. Because now it's connected to this.
Right.
Five, 6. Oh yeah, I'm not sure why I thought that implied stuff, but I'm glad I brought this 5 back at least. Oh, but this still does need to be a 4. Oh! The 4 revealed this to be a cage. It was before that, this was hidden by the fog. And I got confused because it was painted.
So that is a cage.
Yeah. And because of that, this sees all of the same things that this sees. Plus 1, 2, 3. So it can't be a 7 or 8. So that's why we know that this is a 5.
Right.
And this has to be an 8. And now this sees 5, so this must be orange. 7-9 pair makes this a 6. I guess the 5 across the property dot makes it a 6 as well. And the quadruple, there's lots of reasons why it's a 6. 1, 2, 3, 4, 5, 6, 7, 8. One, two, three, four, five, 6. This ends up being blue. Property dot. It has to have either 2 or 6 on it, because 4 and 8 are already used up, which means it's 1 and 3, or 5 and 7. Now, if this was 2 plus 1 or 3, then these are the same, and that is the 1 or the 3 there. But that would take off. Well, that would make this a 4-8 pair, which is fine. It could be that. But if this was 6, well, in either case, this isn't 3-6, because this has to have a 2, which was going to pair with the 1-3 to take 2 and 3 off. And if this is a 6, well then 6 takes the 6 and the 3 off. So 6 and 3 are removed. We know that 4 is one of those two. We just don't know which one yet. So where do we go from here? Know that that's like that. Okay. We know that blue has to connect to this one. But no matter how fancy I connect blue to this one, if I make this blue as well, then we're going to end up locking out orange from being able to connect somehow to this one in the corner. So this has to be orange. And same reasoning applies, this also has to be orange. And I guess if this was blue, the same reasoning applies. If this was blue, then it would have to connect to here, which blocks the orange from being able to reach around. So this ends up being orange as well. And does that same logic mean the rest of this is orange? Because if I were to put a blue here, then I'd have to connect this blue to the rest of the blue somehow.
Yeah.
But then when I do that, I'm going to end up blocking orange. So this can't be blue. The rest of all of that is orange. And I think that wraps all the way around. Because if I were to put a blue anywhere, this then has to connect to blue. But then all of this is cut off. No matter how fancily I do it, let's say I connect to those, but then orange has to connect. No matter how fancily I do it, it's going to block blue. So, and that's regardless of where it's placed around here. This is all orange, which makes this a 9, which has to be next to a blue, and this has to be orange here. And this blue has to be at least 2, and this ends up being orange, so that's a 2, and we've got 1 and 3 here. This can't be 1, so that's a 3, that's a 1, this is a 4, a 5, and we know that they alternate, so this is blue, this one's orange, and we have to have 1, 7, and 9 here. These two aren't 1, so that is.
The 3 in box 3 is on a black cropky dot.
So that's a 6. And this must be blue. And this must be blue because of the cropky dot. This cannot be orange because of the way that stuff works. So this is blue. Because similar to the logic I applied down here, if this is orange, then it's going to have to connect to orange somehow. But however that's done, it's going to block out some blue. So this is blue. You can't have checkerboard patterns in this style of puzzle. Yeah. All right. It has passed 10 o'clock. So let me know how long you want to go.
Yeah.
This has to be 6 or 8 because this has to be odd. We have 3 and then all of the evens. This cannot be 2, this cannot be 3 or 4. But this cropky dot has to have an odd digit on it. So this has to be a 3. And this can't be a 4, so that's a 2. 2 and 3.
Okay, the 6, 8 blue in box 3. It's going to have to extend to the left with blue at least 5 to make the 6.
But it's not
because it doesn't have to see it. It has to see it. Oh, it's not in a cage. Never mind.
Yeah.
Fine.
Yeah. Now, another rule is no 2x2 area is fully shaded or unshaded. So it's neither, there's no 2x2s that are fully orange or green or blue. You'd think I know my colors by now. So these two have to be blue. Could this be 9?
The only way for that to become 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, if it's all blue. But I was gonna say, wouldn't that cut off? But it doesn't.
Yeah, because the orange wraps around. But I think these both have to be blue. Because if these two weren't, then this 7 would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Oh, well, that's perfectly fine.
Well, that 3 has to be blue either way.
Right.
So that 2 has to be orange. And that 1 to the left of that 7, 9 in the center of box has to be blue.
This whole group has to be blue. Because this is 7. And if it's not 7, it's 9, and then it grabs this one and that one. Wait. No. It's either this way, or it has to be 1, 2, 3, 4, 5, 6, 7. The blue goes to there. Which I think is what you were marking, the Discord delay and the streaming delay and all that. 4, 6, and 8 means this is 6 or 8. And this has to be 7 or 5. And then 1, 2, and 3. Out of 2 there. 1, 3 pair there. What's left over in this row? 1, 3, 5, 2, and 6. This isn't a 4. This isn't 7 or 9.
4, 5, 6, and 8 in the column.
4, 5, 6, 8. This isn't 4 or 8. And then these are 6, 7, 8, 9. Or this one's not an 8 because the 1 through 5 here. This has to be orange because no 2x2 group is the same color.
Right.
And then across it must be blue. And I can't have checkerboards, so this is blue. 1, 2, 3, 4. If this is blue, then that would be 6. 1, 2, 3, 4, 5, 6. If it's not blue, then I get both of those. Which, this one is blue, because no 2x2. No 2x2s and no checkerboards.
Right.
But these are an orange-blue pair. I'm pretty sure that's a 2, which is going to place a 2 here.
Yeah, I was thinking the same thing.
Across it, but I don't know whether or not we need to know that until later. Where's 6 in this box? It's not here. It's not there, and those aren't 6. So, this has to be 6 with 5 or 7. Well, this is 5. So this is a 6, 7 pair. That's a 9. This is 1, 2, or 3. And this is a crocodile, so this isn't a 4. Oh, this isn't a 4. This isn't a 4, because of the 4 there. 7, 8, 9 triple
7, 8,
makes
9,
that a 4. Which this could just go left. No, it can't.
Nope.
So it has to go up. Because the most it can go left is 2. So that means it has to go up. So this is done. This is orange. This one's blue. This has to have 8 on it, so this isn't an 8. And it's not a 7 because of the 6, 7 here. So that's an 8, that's a 7, that's not. We don't have 8s, that's 2, that's 4. Not a 2, 1, 3 pair makes that a 2. Not a 2 there. This is a 5, I think. Yep. orange can't go down, so this is blue. Because if it went down, it would be 3.
Right. Well, the blue 4 there in box 8
Is
sees
done.
4.
So orange.
Can't make a blah, blah, checkerboard.
So this is orange, so this is blue.
And blue, that 2, orange 2 is done. And it's in a cage. Oh, I
Yeah.
guess it is already. It was already marked as done, I think.
Yeah, I just marked the 5. Okay. Where do we look next? This has to have 4 or 8 on it, because it sees 6 and 2, which would be 3 and 5 or 7 and 9. Can't be 9, so it's either 7, 8, or 3, 4, or 4, 5. Now this sees all the same digits as this one does. So it's bigger than 2. And it's not 3 or 9. So, okay, if it's at least 4, then that means 1, 2, 3, and if I go 4 in either direction, I add 1 more, so it can't be a 4. So that's 4, 5, or 4, 5 there.
Can't make it to 8.
2, 3, 4, 5, 6, 7. 8's out. And this sees everything that this one sees except for this 1. So the smallest it can be is a 4, but it's not a 4. Because we know that this sees just the row, and this also sees that same row, so it's just missing the column of this one. So the smallest it could be is 1 less than this. And if it's bigger than this one, it's because it goes upwards. Although 1, 2, 3, 4, 5, 6, 7, 8, this can't be a 9. If this is orange, that one's blue, and we end up with a checkerboard. This is blue, and this one's orange. And that's our 1, 2, 3, 4, 5, and 6. So these two are orange. And now we've got 1, 2, 3, 4, and 5. We can't go to 6 without being 7.
Okay, the next to the left of that 5, 7 in orange in box 5,
Uh-huh.
that can't be 5 because it's less than or equal to the one next to it. And it is a cage, isn't it?
Yeah, it is a cage.
Yeah.
But it doesn't have to
So
be
if
less than.
no, but it can't be a 5.
Oh, right, because if it is less than, then it's just the row.
Right.
1, 2, 3, 4, 5, 6.
Yeah. So it could be 6 on the left and 7 on the right.
Yeah. What's left over in this column? 6, 5, and 8. Not a 1, not a 4, not a 1, not 2, or 3. This isn't particularly useful, I don't think. I guess what can this one be? 2, 5, and 9. Alright, so the even digits here is 2 and 4. So you can't get to 7 from 2 or 4. Because 2 is 1 and 3, and 4 is 3 and 5, and there's a 3 there. So 2 and 4 both work. And then even digits over here are 6 and 8. So 1 and 3 are out, because 6 needs to go to 5 or 7, and 8 goes to 7 or 9. So that was a bit more useful than I thought it was. I guess here, 4 and 6 are out as far as evens go, and this one cannot be 2 or 9. So the only way that this one works is if it's an 8, which means that 1, 3, and 5 are out.
Yeah. At box 5, the 6, 7, 8 orange.
Yeah.
It can be 6, but it cannot be 7. It could also be 8. To be 8, it goes, but if it's to be 7, it has to go 6 across and up 1. But if it goes up 1 and stops, then it becomes a checkerboard up there, and you can't do that.
Okay. But if it was 7, then this would have to be a 5, so 1, 2, 3, 4, and that would be blue. Then 5, 6. So that couldn't work in that direction either.
Yeah, but it could be 6 if it's 7 beside it.
Right. But this one couldn't be 7 for another reason.
Right, yeah.
What I was saying, I guess. I'm pretty sure this is a 2. I don't know if we're supposed to go ahead and just plug that in.
Well, the 2 can't go on the top of the 2, and 2's been eliminated, so there's only one spot for a 2.
Right.
And that's clearly a 2 there.
Yeah, okay. 2. So 5, 7, and 8. Not a 2, not a 2. We get a cage here. Oh, and there's a dot, so this is a blue. So this is at least 3. Not a 4. 1, 2, 3, 4, 5, 6, 7. So 8 and 9 are out. 6 is the only.
It can't be 6.
Why not?
Because, well, count it out. 1, 2, 3, 4, 5, 6. That goes to 7.
Oh, right. So this has to be even, which is going to have to be 4 or 8. Which justifies the 3, 5, and the 7. Except 1 and 3.
There's a 1, 3.
Yeah. But 4 is still connected to 5.
Right.
4, 5, 7,
So
8, and 1.
we know blue comes down at least 2 from that 5, 7.
No 2x2s, so this one's orange. And it has to escape. If this was blue, it would create an island.
Right. Two, 3, 4, 5, 6, 7. Okay, so that in box 5, the 6, 8 orange is already at. No, it's at 6. I counted the 6 twice. Sorry.
Now, blue is this group and this group. So we know that one of these two is
Has
blue.
to be blue.
If they were both blue, we'd have an orange group. So one's blue and one is orange. I don't know if there's a reason that one has to be the another.
Oh, box 6,
Uh-huh.
the blue cage is resolved.
Oh, 7, 9, 9, and 7.
9 came out, so 8 came out on the crop key dot in box 6.
8.
Oh no, because
6,
7 can go to 8. Never mind.
6, 8. Four and 8 are still my even digits here.
Right.
If this is orange, we get 8 and... Wait, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we get 8 and 7. If this is blue, we get 5 and 6. But these two are different, because right now they're both at 5, and one of them will become 7, the other will stay at 5. But I guess that just means that this one's not 5 or 7. 2, 3, 5, and 7. 1. I don't know what else that might mean. No 2x2s and no checkerboards, but that's... I mean, we're fine on that front. So we need to find more information. What about these two? We've got a 5-7 pair, so the 7's out of there.
Oh, no. Never mind. That ignore that
5,
O,
7,
because it
2,
was
4,
wrong.
and 8. And this isn't a 6. So where's the 6 in this row? 1, 3, 9, 5, 7, 2, 4, and 8 places a 6. And this is an orange 4. 8 places 7, makes this one blue, makes this one orange. Not an 8. Not an 8 here, not a 4, not a 7. This is odd, so this one is even. 3, 5, and 7 are out.
The crop key dot in box 1 can't be a 5, because it sees both 4 and 6 in the box.
So we get that. 5-7 pair takes a 7 out. 3, 9, and 5.
Box 5, the cages are resolved.
Right, because 1, 2, 3, 4, and 5. and 1, 2, 3, 4, 5, and 6. And this is what, a 4? 6. 3, 9 pair makes that a 5. 8, 7, 5, 4, 6, and 8. That's odd. This
There's
must be even.
a new orange box in box 5.
A 3.
Which is 3.
9, 1, 3, 1, 4, 9, 7, 1, 3, 7, 9, 1, 3, 1, 3, not a 4, not a 6, 5, and 7, 3. I need a 1, 2, 3, I need a 9. I need an 8. I need a 1 in here, so that goes there. I need a 2. Goes here. 3. Here. 4.
The left one is 7.
This is 4 or 6. This is 6, 8, and 5. Not a 6. That is a 6. That's a 4. That's a 9. This is 5 or 8. 8, 5, 6, 8, and 4. And that's done. A little, late. That was a fairly difficult puzzle. But,
That's alright.
A very good one.
That was a good one.
Yeah. If I wasn't familiar with the checkerboard thing, and then the way that this had to be orange all the way around, I think that would have been a lot harder to solve. I mean, it's not impossible to logic that one out, but I think that requires a little bit of trial and error, and knowing that ahead of time is really useful in these types of puzzles.
Yeah.
But yeah. It's like some of the more advanced Sudoku techniques, like the XY wings and stuff like that. Like those are things that you can technically logic them out, but knowing them ahead of time makes things a lot more useful. And things like the Fistmethal ring and set theory and stuff, like some of those types of things you just have to know ahead of time. Otherwise, you're gonna struggle on a lot of puzzles. But yeah, that one was really good. I really enjoyed that. It was challenging. But all right, any comments on any of the puzzles that we solved today?
No, I think we discussed them as we went. So.
Yep. And I did remember to like all the puzzles.
And I actually felt useful on all of them.
Mm-hmm.
Because sometimes it feels like I'm not inputting anything here, but yeah.
Yeah. Yeah. All right, then let's stop recording on that one, and we can I guess just move over to talking. So we will be back tomorrow for Sudoku, unless you have something to say about that, or something happens in between. But other than that, I think that is the end of the stream. So anyone who's watched this far, thank you for watching. Make sure to like, comment, subscribe, all the fancy YouTube engagement stuff. Share the video with your friends, family, people you dislike as well. Share it with everyone. Share it with random people you meet on the bus. Yeah. All right. Then I think that is it. Goodbye.